Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Peripheral devices are external pieces of hardware that connect to a computer or other primary device to add or expand functionality. They are not part of the core internal components like the central processing unit, the random access memory, or the motherboard, but they are essential for daily operation in most environments. Common examples include printers, keyboards, webcams, and external storage drives. In the CompTIA Tech Plus exam FC0-U71, you will be expected to recognize different types of peripherals and understand how they are installed, configured, and maintained. Peripheral devices can be grouped into categories based on their primary function. Input devices are used to send data to a computer and include hardware such as keyboards, mice, scanners, and microphones. Output devices present information from the computer to the user and include printers, speakers, and display screens. Some devices combine both input and output functions, such as touchscreens, headsets, and all-in-one printers. Storage peripherals include external hard disk drives, external solid-state drives, and flash drives that are used for backup, data transfer, or expanding available space. Many modern peripherals are plug-and-play, abbreviated as PNP, meaning they are automatically detected and configured by the operating system when connected. Most devices that connect via USB or through a wireless interface support plug-and-play. When detected, the operating system will automatically install the required drivers or download them from the internet if needed. This type of installation greatly reduces setup time for end users and simplifies configuration for IT support teams. Some devices, especially specialized or advanced models, require manual driver installation. This may involve downloading the driver package from the manufacturer's website or installing it from an included disk. Manual installation is often necessary for advanced printers, high-resolution webcams, or specialized gaming accessories. Drivers must match the device model and the version of the operating system to ensure compatibility. IT support professionals may need to manage driver updates and troubleshoot issues when older hardware is paired with newer systems. USB connectivity is the most common physical interface for peripherals. Common connector types include USB Type-A, USB Type-B, and USB Type-C. Versions such as USB 2.0, 3.0, and 3.1 or 3.2 differ in maximum data transfer speed and power delivery capabilities. For best performance, devices should be connected to the highest speed port available. USB Type-C is a reversible connector that can carry data, video, and power over a single cable, and is increasingly common in modern devices. Wireless peripherals connect without a physical cable and may use Bluetooth, radio frequency, abbreviated as RF, or Wi-Fi. Bluetooth is common for keyboards, mice, and portable speakers and requires pairing with the host device. RF devices often come with a dedicated USB dongle and offer simple plug-and-play operation. Wi-Fi-enabled peripherals, such as network printers, may require network setup, including Internet Protocol configuration, before they can be used. Internet Protocol-based peripherals are devices that operate over a network using TCP/IP protocols. Examples include network printers, network scanners, IP cameras, and smart displays. Installation may involve assigning a static or dynamic IP address, either manually or via dynamic host configuration protocol. Configuration can be done using network discovery tools or device-specific setup utilities. Some Internet Protocol-based devices host a web-based configuration interface. This is accessed by entering the device's IP address into a web browser. The interface may allow firmware updates, security setting adjustments, user account management, and review of usage logs. This type of setup is common for enterprise-grade printers, IP surveillance cameras, and network-attached storage systems. Display devices are a key category of output peripheral. These include computer monitors, digital projectors, and smart televisions. They may connect via HDMI, DisplayPort, VGA, DVI, or USB Type-C. Modern operating systems can detect new displays automatically and allow users to configure resolution, refresh rate, and screen orientation. Multi-display setups can be extended to increase workspace, mirrored for presentations, or assigned as primary displays. Audio peripherals include speakers, headsets, microphones, and soundbars. They may connect via an analog 3.5mm audio jack, USB, or Bluetooth. In the operating system, you can select the default input and output device and adjust sound profiles. Proper microphone and speaker configuration is important for voice calls, video conferencing, and multimedia production. Specialized input devices perform niche functions. Scanners digitize documents and photographs. Webcams capture live video for conferencing or recording, and game controllers provide enhanced control for gaming applications. Graphic tablets allow artists to draw directly into software, and biometric devices such as fingerprint readers add security. Some of these devices require calibration or manufacturer-provided software to function fully. An uninterruptible power supply, abbreviated as UPS, is a peripheral that provides battery backup to protect computers and other electronics during power outages. A UPS connects to the computer via USB or serial cable, so it can manage shutdown procedures automatically if the power fails. It also provides protection against voltage spikes and drops. Installation typically includes inserting or activating the battery, connecting equipment, configuring included software, and testing the failover process. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. External storage devices are one of the most common peripherals in both home and business environments. These include external hard disk drives, external solid-state drives, and portable flash drives. They connect through USB, Thunderbolt, or USB Type-C and are usually recognized automatically by modern operating systems. Depending on the intended use, they may be formatted in file systems such as FAT32, XFAT, or NTFS. External storage can be used for backups, transferring large files between systems, serving as bootable media, or providing secondary storage for devices with limited internal capacity. Printer installation and configuration vary depending on the connection type and the printer model. Local printers may connect via USB and install automatically as plug-and-play devices, while network printers can connect via Wi-Fi or Ethernet. For network-connected printers, setup often includes assigning a static or dynamic IP address, configuring print queues, and setting permissions for specific users. Some printers require downloading and installing a driver package from the manufacturer's website to enable advanced features or ensure compatibility with the operating system. Scanners and multifunction devices require both hardware connection and software configuration. A standalone scanner captures documents or photos and converts them into digital formats such as PDF or JPEGs. Multifunction devices combine printing, scanning, copying, and sometimes faxing into a single unit. Scanning software or built-in operating system tools control settings like resolution, color depth, and output format. For network scanning, you may need to install specific driver packages and configure destination folders or email delivery settings. Peripheral devices can sometimes experience conflicts, particularly when two devices attempt to use the same system resource or port. This can happen if two devices share the same IRQ assignment or if a new device is plugged into a faulty USB port. The device manager in the operating system can identify malfunctioning or unrecognized devices, often with a warning icon. Troubleshooting steps include updating or reinstalling drivers, changing port assignments, disabling duplicate entries, or simply rebooting the system. Reseating cables and reconnecting devices can also resolve detection issues. Proper driver management is essential for peripheral stability and performance. Whenever possible, drivers should be obtained directly from the manufacturer's website or through the operating system's built-in update tools. Avoid third-party driver sites, as they may host outdated or malicious software. Keeping drivers up to date ensures compatibility with system updates, fixes known bugs, and closes security vulnerabilities. If a new driver causes instability, the operating system often provides a rollback feature to restore the previous version. Firmware updates are another aspect of maintaining peripherals. Firmware is the embedded software stored on the device itself, and updates can add new features, improve performance, or fix bugs. These updates are typically applied through manufacturer's software tools or via a web-based configuration interface. Before updating firmware, always verify that the update is intended for your exact device model and back up any settings, as updates can sometimes reset configurations. Failed updates may require a factory reset or reinstallation. Accessibility and ergonomic devices are specialized peripherals designed to improve usability for individuals with disabilities or physical limitations. Examples include large print keyboards, trackballs, adaptive switches, and screen readers. Installing these devices may require additional software support and user training to ensure they are configured for the individual's needs. In both educational and professional settings, accessibility peripherals enhance productivity and promote inclusivity. Peripheral use cases vary by environment. Home users may rely on plug-and-play printers, webcams, and wireless keyboards that are easy to set up and use. Office environments often require shared network printers, IP phones, and uninterruptible power supplies for critical equipment. IT support centers frequently use specialized diagnostic tools and hardware duplicators to image drives. Educational institutions deploy document cameras, digital projectors, and centralized charging stations for devices like tablets or laptops. In exam-focused scenarios, the CompTIA Tech Plus may present questions such as printer not detected or audio device not working. You will need to identify the necessary installation or troubleshooting steps, which could include checking connections, installing or updating drivers, configuring IP settings, or verifying default device selections. The exam may also require comparing plug-and-play setup with manual driver installation or explaining the process for configuring an IP-based peripheral. Recognizing device types, ports, and interfaces is critical for accurate answers. Key glossary terms to review for this topic include PNP, USB Type-C, IP-based peripheral, driver, firmware, uninterruptible power supply, display output, and Bluetooth. Reviewing these terms in both acronym form and full description will help with quick recall on the exam. Flashcards, device labeling exercises, and glossary-focused study can reinforce understanding. In real-world technical support roles, setting up and maintaining peripheral devices is a daily responsibility. Understanding installation methods, driver requirements, firmware management, and network configuration improves first-call resolution rates and reduces downtime. Proper configuration also enhances device security, usability, and performance. These skills apply across multiple environments, from individual home offices to large enterprise deployments. Peripheral maintenance follows several best practices. Keep firmware and drivers current to maintain functionality and patch vulnerabilities. Label and organize cables for easier management and faster troubleshooting. Educate users on the correct handling and configuration limits of their devices. Maintain a small inventory of spare devices, adapters, and cables so replacements can be provided quickly when needed. In the next episode, we will explore installation types in more detail, focusing specifically on plug-and-play versus manual driver installation. You will learn how these methods affect compatibility, performance, and configuration options, both in exam scenarios and real-world support work. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.